Okay, we're going to continue on with the presentation on Chapter 33. And these are the questions that were at the end of those overheads that you answered. I want to make certain I go over them so that there's no misunderstanding about any of them. It does take a bit of thought, but I think it's important in order to understand the concepts that we're talking about here. Once we get finished with these, we will then continue on and do the lecture on Chapter 34 and the problems that you will have to do for Thursday. Thursday, those problems will be due. The answers to the multiple choice questions at the end of 34 will also be due on Thursday, and then there will be a lab that we'll do at that time as well. I will try to include all that material so you have that. And at the beginning of the section when we are doing Chapter 34, as well as online, I will put the problem numbers that are due at the end of Chapter 34. Okay, so the first one. Consider the region of space you are occupying. Which of the following types of electromagnetic waves are present around you? And of course, the answer here is E, all of them. And, I guess I need to switch this over so I can do the slideshow. Okay. Now, for the next one. For which one of the following properties do visible light and ultraviolet waves have the same value? And of course, the only correct value there is speed. The other ones all change depending upon the specific wavelength, frequency, energy, or period of the different ones. The correct order, beginning with longest wavelengths and extending the shortest, of course, is red, yellow, green, blue, violet. The answer there is A. At a point far from an antenna, the electric field of a radio wave is directed in the positive Y direction as the wave travels in the negative X direction. Which one of the following statements correctly describes the magnetic field component of the wave at that location? And the answer there is D. The magnetic field component is in phase with the electric field component, and it's directed in the negative Z direction. Okay. About how many times faster is the speed of light compared to the speed of sound? And that is 1,000,000 times. The answer is E. In 1667, Galileo attempted to measure the speed of light by having two people hold covered lanterns on hills that were about 1.5 kilometers apart. One person would measure time. One of the people with the lantern would uncover it. The other person would then uncover his lantern when he saw the light from the first lantern. Repeated attempts failed. Essentially, they're just able to measure what their reaction time was. The reason for that is when you do the calculation, you'll find out that the time would have been 5 microseconds. And none of us have reaction times faster than that. If you're standing on the side of an opaque closed box, there's a hole right here. There's a light here. You look through this. All these walls are painted black. What do you see? And the answer is E, nothing. None of the light here is on a direct line with this. So there is no way any light could get through it. All the black surfaces would absorb the light that was emitted by the light bulb. Number 8. The monochromatic electromagnetic radiation illuminates an area of a surface. The electric and magnetic fields of the waves are then doubled in magnitude. Okay? No, we skipped. Yes, that's 7. Okay, this is 8. And then how is the total energy incident on the surface of per unit time affected by the increase? And that is, if that's doubled, this right here is by a factor of 4. So the answer there is C. Number 9. The amplitude of a magnetic wave, field component of an electromagnetic wave 1 is B. If the amplitude for wave 2 is 2b, well, how does the intensity? Okay, the intensity is wave 2 is 4 times larger than wave 1. Because that is squared, right? Number 10. In which of the following cases is the largest force exerted on an object by electromagnetic radiation? And when the radiation is reflected back along its incidence path, the answer is D. Number 11. Unpolarized light with an intensity S is incident on a series of polarizing sheets. The first sheet has a transmission axis oriented to 0. A second polarizer has a transmission axis oriented at 45 degrees, and a third at 90 degrees. Determine the fraction of light intensity exiting the third sheet with and without the second sheet present. Okay, with the second sheet present, it's going to be 0.25 S. Without the second sheet present, it's going to be 0. Number 12. Horizontally polarized light of intensity S is incident on a polarizer with a transmission axis oriented at 45 degrees. Determine the fraction of light intensity that goes through there. And this is 1/2 of that point, so the answer is C. Now 13. Unpolarized light of intensity S is directed through 3 polarizing sheets. The first sheet is polarized vertically, the last sheet horizontally. If the middle sheet is also oriented vertically, what's the intensity? And the answer would be 0, A. Which one of the following statements most closely describes how humans see objects? And that is, some objects are sources of visible light, others are seen when visible light scatters from them. That's how we see them. Okay? 15. You are talking with a friend in a closed room with no windows, no objects, no furniture. The only thing in the room is an overhead incandescent light that is turned on. You're looking at your friend and begin thinking about whether you are seeing your friend as a result of reflection. Does reflection play a role in seeing your friend? And the answer is D, yes. The visible light from the overhead light bulb is diffusely reflected, not like a mirror, from my friend and enters my eye. This is a diffuse reflection, right? That's why we see underneath trees and other places like that. Okay? So the answer 15 is D. 16. In which of the following cases, if any, does the angle of reflection not equal the angle of incidence? And in all of those cases, in all above cases, the angle of reflection will equal the angle of incidence. So the answer there is E. That's always going to be the case. Verse 17. Is light bent more or less or not at all when entering a medium with a larger index of refraction than incident medium? And the answer there is A. It is bent more. Okay. Oops, sorry, wrong way. Number 18. Is light bent more or less or not at all when entering a medium with a smaller index of refraction than incident medium? And the answer there is less. Okay. Complete the following statement. Chromatic dispersion occurs in some materials because different wavelengths of light, and 2 of the above answers are correct, right? Okay. Because different wavelengths propagate are reflected at different angles, okay, and are different indices of refraction. So the answers would have been B and D, so those are the 2 that are correct. The speeds are the same. Which of the following is an example of chromatic dispersion? And the answer is A rainbow seeming to connect 2 mountain peaks. Okay. 21. You are in a closed room with no windows, only one source of light, overhead incandescent bulb. Around the room, you notice various objects, yellow banana, red apple, green cucumber. Which of the following best explains what influences the color and brightness. And of course, the answer there is B. Some of the white light is absorbed by the banana, but the proportion of the spectrum that is yellow is reflected. So each one of them, the color that you're seeing, that is what is reflected by that one, and the rest are absorbed by that one, right? So the answer is 21B. 22. Which of the following substances does light have the largest speed? Okay, and the answer is have the largest speed. The answer is D, and water. Okay, it depends upon the index of refraction. Well, it depends upon. Oh, this thing is just jumping around on me. Sorry about that. Usually when we see a rainbow, we see a single bow with a red at top, violet at the bottom. The process of rainbow is described in the text. You see a double rainbow, one below the other. Okay? Which of the following best provides explanation of the double rainbow? And the answer is B. The upper rainbow is formed from water droplets that are higher than those that form the lower one. It is formed by light that is reflected 2 times within multiple water droplets, unlike single reflections within multiple droplets that form the lower rainbow. And the next one. If total internal reflection is to occur, what must be the incident light? It must be larger than or equal to the critical angle. The answer is 25 is B. And then finally 26. A beam of unpolarized light is directed at a liquid within a transparent container. When the light strikes the airless liquid's interface, all the rest of this, what does Jason observe when the transmission axis of the polarizer is perpendicular? He observes no light is transmitted through the polarizer because it's perpendicular to that. Okay, that ends this. We'll start off the next video with the material from chapter 34.